we're moving away from the source now. We're looking at the treatment part, the disinfection part of the multi-barrier approach to protection. So in the first level there, you saw source water protection. We did a little bit on that, and now we're into drinking water treatment. And the purpose of this next little bit, so there's a lot of kind of technical skills maybe you'd want to develop as an operator. We're not going to cover a lot of them. We're just covering a couple of small things, and we're trying to look at a couple of things that would be approachable to a few members of the community and how you could build up capacity just outside that one main operator to try to make that main operator's life a little more easier. And the big thing to remember here, and it's kind of the common theme, is there might be some things coming up throughout the day where you're not fully sure of how you would handle this, or you want to know more about it. You got to reach out and try to find some more education. That educational opportunity is probably out there. So if you're in a community and today you're thinking, I'd like to know a bit more about disinfection, you're reaching out to Deneen's group to say, I'd love to sign up for that training. Can you come help me? So if we're looking at level 1 drinking water treatment, disinfection is the most critical part. You've got to disinfect. If you're taking water from even a beautifully clean source, a wonderful groundwater well, if you're not disinfecting, you can't be off a boil water advisory because you can't guarantee the safety of the water as it's going to eventually reach people. So your big goal, you want to inactivate or kill any of the threats that might make its way to the consumer. And here in Newfoundland, most of it's being done by disinfection. Most small communities have kind of a straightforward enough system that there's just a dosing pump, adding some chlorine to the water, and it's going out to the people in the community. There's a standard to that system's design where, if we're thinking back to Henrietta Chick in the 1900s, she said, add the right amount of disinfectant for the right amount of time. So we still have that today. We've got the idea that water, as it enters into the distribution system, on its way to the first user, it had to have the right amount of time to disinfect, and it had to be at the right strength. So that's something called the CT factor. And probably some of you are familiar with it, some of you might not be. The idea is your system was designed to give a CT equivalent of 6. So a concentration was large enough and the right amount of time was large enough. They came together to say that would be secure for this system. There's handouts that are in the back and are available on the government website that's going to run you through how to do a CT calculation if you want to. That calculation is a little bit involved, but it's not too technical. It's mostly just how many people are using the system. If you're not measuring your flow, if you know there's 100 people on the system, you can kind of get an idea of how much water probably goes out into the community on a daily basis. You need to know a little bit about the demand on the system, so that flow out. You need to know a little bit about your infrastructure, like how long does it take before water goes in a pipe and makes it to the first person. You're looking at things like that, eventually coming together to get a CT check. And we're not going to go more beyond that today. If you wanted to know more about your community's CT factor, you could contact Municipal Affairs and Environment, or you could work through one of these worksheets just to see, are we doing things the right way? It's that idea that a lot of communities, they don't really know where they're going with their disinfection. They maybe 10 years ago, someone came and installed a pump and then didn't give them any more guidance on why you're adding this much chlorine today. You need this much chlorine because you've got this much water leaving the system, and that's how you keep it safe. There's got to be a bit of a refresher for some communities where they go in and say, am I mixing up enough chlorine strength? Is that disinfection strong enough for how much time I have before it reaches the first person? We've mentioned it earlier, but there are some really great videos on YouTube where you can go to the Water Resources channel and you can spend 10, 15 minutes. This is a video, we won't do it here today. This is one that if a community is feeling a bit unsure about, how do I kind of mix up new chlorine? It's like following a recipe. They have to have a guide on how much water, how much chlorine should be added to get the strength. The video runs through how to kind of take care of that part of the disinfection process. So if you're never in the pump house, if you're a government official or you don't really go in on that side of things, that's a great introduction to what you need to do. It's straightforward enough that if you're in a community and no one's stepping up to say, I don't want to be an operator, they should see that, okay, maybe I could get a bit more training here. I could learn how to do that. It's not too bad. We've also got a video that will run through another aspect. So it's the chlorine residual. And the residual is that part, we'll talk about it in the distribution side of things in a little bit. Once you add your chlorine, and it has enough time to do its work on whatever might be in the water, goes out into the system, you have to make sure that the chlorine stays active. There's a secondary level of disinfection maintained so that the person at the end of the system is still getting some sort of protection. There's enough chlorine being left in the water to keep them safe. To test chlorine and the residual level, that concentration, there's something called the colorimeter. And we're going to take maybe 10, 15 minutes right now to run through how do you use one. Probably you've never used one before. If you're a government official, maybe you have used one before. If you're an operator, you use it on a daily basis. We've had a lot of communities that add chlorine to their system, but have never ever used a colorimeter and have never checked their chlorine strength. So they have no idea how much chlorine is in the water. You really can't tell. Unless you go out and do a measurement of the chlorine strength, you're just guessing. So this is something that I think through the demonstration you'll see there's not that much to it. It's just a bit of a process to learn. Maybe you spend 10 minutes getting comfortable with the unit, which hopefully you will be by the time this is over, and you'll see, okay, I should be checking my chlorine residual. We've covered it earlier about you need to have the right amount of chlorine, and you can teach other people in your community to do it. So let's spend some time just getting more familiar with it. You've all got one on your table, and hopefully you can open it up and kind of follow along.
My name is Jerry Leahy. I'm with the Operator Education, Training and Certification section. I'm with Denine's group. As she mentioned earlier, I'm the operator trainer for the West Coast and Labrador region. Some of you may know me, most of you would be dealing with Darren if you're out here on the East Coast. So what we're going to do is we're going to do a little run through of a typical residual test. Anybody that's here from a town or an EHO will have done this test a bunch of times before, but we're going to go through the process. They're relatively simple. So one thing we're going to point out, this method is going to be for the kit we have here today, which is a Hawk Pocket Colorimeter 2. What we're starting to see out in the field is another couple of companies are starting to sell colorimeters, and we're starting to see those in the field. So if anybody is out and an operator is using a different kit, then we always recommend using whatever the exact instructions are for that kit, because everybody's kit seems like it has a little variation in the instruction on how to do it. So what we're going to do today is for the Hawk Colorimeter 2. And like I said, if you're ever in the field and you encounter a different model or brand, then check with those instructions. So as the name says, this is a meter that measures color. It's a pocket colorimeter. So what we're doing in this test is we're going to add a little DPD reagent that has iodine and stuff in it. And if there's any chlorine in that water, it will turn pink. And what we're going to do then is we're going to put the sample in this kit, and when we press read, it is going to shoot a little light through it, and it's going to measure how much light gets through. So that's how this kit is measuring chlorine. The chemical that's in the little silver packet is reacting with the chlorine that's in the water, and then depending on how dark the water gets, it's measuring how much light gets through and then calculating a chlorine value. So this particular one is for free and total chlorine. You can get different ones. The difference in those is that there's going to be a different light and filter system in it. So if it's for measuring ammonia or something like that, the kit will look the same, but it won't be the exact same light sensor. So the first thing we're going to do is we're going to take out our low range bottles. So you'll notice that there's two different types of bottles in this kit. So you've got a glass sample cell and you've got a plastic sample cell. So your glass sample cell is for your low range. So that's if you're going to be measuring a chlorine residual of anywhere around 2 milligrams per liter or lower, down to a 0.02. If you're doing a test and you get a flashing 2.20, that tells you that you've got a chlorine concentration higher than 2, then you're going to switch to the plastic bottle, which is for the high range. The difference in the two bottles, if you look at the bottom of them, is the thickness that's through. So the high range bottle is a little thinner. If anybody has the really old Hawk kit that is still light blue like this, it was a little thin test tube that was in it. So what happens is, depending if you're in the right range mode, whether it's low range or high range, it's measuring how much light is getting through. So it's programmed to read the amount of light based on this width. So if you use the low range and you're in the high range of the kit, your number is going to be about 2.5 times higher than it is. So we've seen that a lot in the past over the years. If people didn't realize they were in the high range, and then they did a test, and then all of a sudden their numbers were crazy, and then people would call back and say, what's going on? We determined they were using the wrong bottle. So the first thing you do, you're going to run your water from a tap. You want to do it 5-10 minutes. If you're unfamiliar with how big the water line is coming into that facility, you want to run it till you've got a steady temperature. Not everyone's carrying a thermometer around, but it's a good idea if you put a thermometer there. Once the temperature stabilizes, then you know you're getting water that's from the distribution main. If you're, say, taking a residual at a town council building that has a volunteer fire department, you might have like a 4-inch line coming in there, and that might take 20 minutes or a half hour before you're getting fresh water from the main. We've seen a lot of that over the years. If people weren't sure what size line was coming into the building, they were wondering why they couldn't get a chlorine residual, but after running the water for, say, 20 minutes, the water was fresh enough from the line that you could get the higher residual. So the first thing you're going to do is you're going to take a sample from your tap. So everyone's got your water there. So we're going to fill it up to the little line, the 10 ml line that's on the bottle. So we're going to fill it up to here. So the amount of chemical that's in this envelope is made to react with this volume of water. So in order to turn on our kit, you'll notice there's 4 buttons on our kit. We've got a green read button, a blue 0 button, a menu button, that's 4 little lines, and our power button. So we're going to turn on our power button. And what you'll see is whatever the last residual taken with this kit was, that's the one that pops up there. So the first thing we're going to look for is, you can see on the top left of the display there should be a little triangle pointing at LR. That means you're in the low range. So that's the range we're going to test in first. So the first thing we're going to do is we're going to take a sample cell. If you look on the sample cell, there's a little diamond on it. So we're going to place the sample cell in the kit with the diamond facing back towards us. And the reason for that is, say if this sample cell is scratched or has some imperfection on it, because it's measuring light going through, passing through that bottle, that will affect the number. But if the diamond is always facing back at us, at least that imperfection will be in the same place all the time. So it'll be making the same mistake every time. So have your diamond facing back at you. You want to put your cap on the top of your colorimeter. It has to be secure. It can only fit on there one way. The reason for this is because we're trying to measure how much light is passing through this sample cell. If light doesn't get through it, or we get inside interference from light from outside, it won't read properly. So the first thing we're going to do is we're going to put our cap on, and now we're going to press our blue 0 button. And it should come up with 0.00. So the reason we're zeroing it is, even if our water has a bit of natural color to it, if you're somewhere where there's highly organic water, we're now going to look for a change in that color. Because if the water was naturally yellow and you just put it in, it would impact how much light is getting through and would give you a false positive. I had an operator about 20 years ago, 18 years ago, that used to use distilled water for his colorimeter zeroing. He would zero it with distilled water, and then he would do a sample. So he always got a higher number than he should have had. So the next thing we're going to do is we're going to take our sample cell back out, and we're going to take our packets. So you'll notice that there's 2 sets of packets in there. One is for your free chlorine, one is for your total chlorine. So the first test we're going to do is going to be a free chlorine test. So the first one we're going to do is the free. You can see on the little packet and envelope it says free chlorine on it, and it also has an expiry date on it. So they're generally, once you get them, they're good for about 4 or 5 years. But just last month I may have been into a town and opened up a test kit, and the packets that were in there expired in 2006. So it's not uncommon to see them lying around buildings. So then what we're going to do is, a handy thing to do is tap the bottom of the envelope, get your powder back down to the bottom, tear open our envelope. It's handy to have a little pair of scissors in your kit, or nail clippers, right? So I'm going to put my powder in there. So what I'm going to do then is I'm going to shake it gently. So sometimes you might see a little bit of powder left in the bottom of the bottle. That is okay. As much of it that needs to react will react. So for free chlorine, you have to wait 20 seconds, and you have to do the test before a minute is up. And the reason for that is the free chlorine reaction happens almost instantaneously. So when you're testing free, you got to wait about 20 seconds, but do it before a minute is up. If you wait too long, if there's any large amounts of monochloramine in there, it could cause a drift and you'll get a higher number. I used to have another operator back in the day that if he didn't like his residual now, he'd put it on the shelf and come back 2 hours later and then have a higher number. And he didn't know he was doing wrong, you know, but he did recognize that the longer he left it, the darker it would get. So like I said, after 20 seconds and before a minute is up, put it on again with the diamond facing back at me. I'm going to put my cap back on, and I'm going to hit my green read button. And then I should get my free chlorine residual. So I got 1.31. Everyone got around the same? Okay. Well, that's the thing. When you're doing this all the time, you'll get a feel for it. I know there's one home in, I believe it might be, I don't know if it's Portland Creek on the Northern Penn or not, but the EHO goes there all the time, and our sampler goes there all the time. So the person that lives in this house is used to seeing the test done, so he gets a kick out of doing it by taste. Oh, it's about 0.96 today. And our sampler, Carla, she tells me he's pretty accurate a lot of the time. So if you're familiar with it, like I said, you'll recognize. So if there's any pink there at all, if there's any chlorine there, it'll turn pink, and you'll visually be able to see it. So the rule is we're looking for a detectable residual at the end of the line. So that's not a very finite number. So what is detectable? So this is a field kit. So you have to remember that this is a field kit. This is not an amperometric titration that's done in a lab. So for safety's sake, what we're communicating to operators is we would like it to see it between 0.05 and 0.10 milligrams per liter for safety's sake to say it's detectable, right? So if someone wants to take it as lower, like say if an EHO is comfortable enough with the operation of that system that they would accept 0.04, you know those people generally keep chlorine in. That's your call and stuff. So, but just for, I know the EHOs that are here, for what we're communicating is for safety's sake, we're trying to get the operators to keep it around 0.09, 0.10, just so you know that it's detectable. The kits will say they're good to plus or minus 0.02, and then there's plus or minus a % on that. So like I said, we would like to see it around 0.05 just for safety's sake. So for the total residual test, you do it the exact same way, except you use the total pillow, and the only difference is you have to wait 3 minutes, and you have to do it before 6 minutes is up. And the reason for that is it takes a little longer for the color to develop, and so that's why we wait those 3 minutes. It seems like eternity when you're there waiting, I know, but it's a good practice to fill up both samples, put one aside for your total, and then do your free. The zeroing, once you zero it once, it's okay. One item of note, it's better, Hawk will tell you to have 1 bottle assigned for free and 1 bottle assigned for total. And the reason for that is some of the iodide that is used in the total determination can give you a false positive in the free. So there's been debate over the year. For this Hawk kit, it actually says use a separate bottle, 1 for free and 1 for total. So it's good for an operator to put a T on one and an F on the other. Some of the other kits, their method will be different. I know the old Prominent kits, and I believe the Lamont kits actually ask you to do it in the same bottle. So again, go back to the manufacturer's specifications with regards to whichever kit you happen to be encountering. Because like I said, we're starting to see another couple of brands showing up out in the field. The Water Resources Management, we buy secondary standards every year. What they are is we get 4 cylinders. Pardon?
I forgot the nearest standards out in the MTU.
Yeah, I know. I didn't bring them in either. So what it is, it's 4 little vials that we get. One is a 0, and it's 3 values, usually around 0.21, another one at 0.86, and one at 1.56. They expire every so often, so we buy new ones. So we communicate to towns and anybody else. If we're in the area, we can check your kit. What it is, because it's a known value, we can see if your kit is drifting. So the proper way to use them is when you first get the kit, you measure it, and then you write it down. Then the second time you test it, you see if your kit is straying from that value. Because what you'll find is sometimes kits will start to drift in either a high or a low range. Just last week I did a kit out in Kippens on the west coast. They were perfect in around 0.21. At around 0.86 they were a little high, and by the time they got up above 1, their kit was way off. So we buy those because they expire. We keep them for our sampling people. So if you want access to them, get a hold of your local operator trainer and we can hook up with you and check your kit. If you need to do a high range test, the instructions are there. We have some laminated instruction sheets for how to do the tests in the back. They're laminated so that if they're in a pump house and they get wet, it'll be okay. The instructions for doing the high range is in there. You just use 2 packets. So to switch your kit from the low to the high range, you hit your menu button, that little button in the middle with the 4 lines on it. You hit that once. Then what you do is you hit the green button, and you'll notice the blinking arrow will move over to the HR. Now you're in the high range. If you hit the menu button again, you'll be in the high range. And if you're ever unsure, when you're in the high range, whether it's this one or the older light blue hot colorimeter, if it's only 2 digits, 0.0, that tells you you're in the high range. So even if you don't have to rely on that little arrow that's there, just looking at the number of digits on the screen will tell you what range you're in. The light blue ones, what you got to do is there's 2 buttons on that one. You hold both buttons down for about 1.5 seconds, and after 1.5 seconds, you remove your left thumb from the 0 button, and it switches range. So there's no arrow on it to tell you which range you're in, but again, the number of digits will do that for you. So remember, this is a field kit. They're not going to be super accurate. There's a range. So if you told me that you got 0.51 one day and then 0.56 the next day, that's the same number. Like, that's close enough in the range with these kits. That is close enough. I wouldn't call that a change. If an operator called me, I had one guy used to try to keep it at 0.50. If he got 0.49, he'd turn up the chlorine. If he got 0.51, he'd turn it down. He drove himself crazy for years. Right? But the kits are not that accurate. Remember, this is a field kit. Sometimes operators, if they find water coming up on the side of the road, they'll take out this kit and test it, and it'll turn pink, and they think they might have town water there. That is not really recommended because there are a number of things that can interfere and give you a false positive. Any iron and manganese, mostly manganese, will make it turn pink. So I've seen residuals on people's front lawns of 0.21 in a place where I couldn't get 0.05 out of the tap. And unfortunately, if a resident sees you there with it turning pink, there's no way you're going to convince them that that's not a town leak. If you feel the need to do that, you can buy 2 chemicals from Atlantic Purification Systems that will remove the chlorine. So you can run 2 tests concurrently. You can do one, and then you do a second one taking the chlorine out, and you can just subtract the 2 numbers. So that will give you a presence, and I've done it with numbers up around 2.75 and low numbers. So it does work for that. If you really feel the need to do that, both it's potassium iodide and sodium arsenite. It only takes another couple of minutes to do that test. And the chemicals are really about 25 bucks a bottle, so they're not expensive to get. So if you feel the need to do that, there are chemicals available, but I wouldn't recommend doing it to try and trace a leak. Are there any questions?
So if we kind of reconvene, before we leave the world of disinfection, we'll just have a couple little reminders. So I think in doing the little demonstration with the colorimeter, some of you are probably so familiar with it that, of course, this thing's easy to use. I use it all the time. The purpose of this, and these sessions today will end up online, so there's going to be people maybe seeing this who have never used one before, but really it's an approachable thing. It's a really simple tool that's really important. Without it, again, you don't know what's happening in your system. You can't. Some people rely on just taking measurements in their point of disinfection, say inside their pump house. An operator who just goes there never goes out into the field with his handheld unit, never takes those samples out there. To get off a boil water advisory, if you're a community that's on a boil water advisory and you want to have it lift it, you're going to have to prove to an EHO and anyone else involved that you're getting your right amount of disinfection in the beginning. You took your measurement, you know, okay, right amount of chlorine is being added, and you've gone out to your system to find out that chlorine stays in that system. And you got to have a test in the beginning, the first user, tests out in the middle to see how the system's behaving, and at the end. So what's that mean? Well, it really depends on your system. The design of your system as a community can vary. Some communities, this is in Labrador, this is Hopedale, they have a looping system that goes in all sorts of different directions. So that's a community that they couldn't just say, take a chlorine residual measurement inside of their building where they disinfect. Because once it leaves the building, water has a lot of opportunities to go in different ways. So they've got a responsibility to go out to these different locations, take out their colorimeter, and check every day what the chlorine residual is to make sure it's where it should be. If it's not where it is, that's when you're reaching out to someone to say, I've got a problem, there's no chlorine here, what can I do? So earlier, we're not going to do it now, but on that same boil water advisory assessment tool, you looked at source water. There's a disinfection page in there, so a community could open it up and run through some of the questions that are going to leap out. Do you have a colorimeter? If a community says, nope, never even heard of one, that's a big risk. You know that that community has to get up to speed on why colorimeter is important, why they need to start using it on a daily basis. There's a lot of communities that we've worked with that they haven't had chlorine disinfection for a while, or they have had chlorine, but they haven't done colorimeter testing. They haven't gone out to check chlorine residuals. A lot of times in those communities, there's some fear or stigma associated with chlorine. People who say, I won't touch that water if there's chlorine in it. It's gross. I can't taste, like I can't consume that. Because people do get sensitive to certain levels of chlorine. You can't just keep adding chlorine to water. There's a balance. It can't be too high. Eventually, it will be non-consumable. You couldn't drink it. If it's too low, it's not the right amount of disinfection. So there's somewhere in the middle that you want to be as a community. So each community has that responsibility to, on a daily basis, check in, see where the chlorine is, make sure it's in the right range, get colorimeters out in the system. A lot of communities that are smaller might have an operator who's a volunteer. That volunteer is also the plowman. Does a lot of different things in that community. They're probably going to instinctively say, I've never done colorimeter testing before. You're telling me I got to do it on a daily basis, and I've got to go out to all these different areas. I'm not going to do that. I don't have time. If a volunteer is in that position, and that's maybe a valid thing, maybe they don't have time. They've already got to deal with breaks. They've got to deal with all sorts of different things in a sort of short amount of time for no money. How do you make it easier on them? Some communities that we've met with, they recognize that as being a bit of a weakness. One person who couldn't do it all. So they went out, they found other people in the community to get trained up on how to use a colorimeter, and then they're responsible for that daily check. In their own house, they can open the taps, they have their own colorimeter, the community bought a few of them. They run it, mark down the results. They might at the end of the week phone in the observations to the operator. If something was unusual, like there's no chlorine that day, they're going to reach out to the operator. That's going to come in handy for those situations where an operator is a volunteer by himself or herself, and they want to leave to go on vacation. There's a lot of communities that the person leaves and no one else steps in and takes those measurements. So the more of that capacity that a community has to have multiple people sharing responsibility, the better. If you are a community that wants to pursue getting colorimeters and getting that process in, you should reach out to Municipal Affairs to kind of learn a bit more. If you're dealing with really high chlorine or really low chlorine, maybe it's at the point of application of chlorine that you need to adjust something. Maybe you've been adding too much because you've never measured your residual before. That's probably why people were complaining before, because you were just guessing, putting in a bunch of chlorine that wasn't even appropriate for how much water you use. Or maybe there's something else going on in your system. We're going to look at distribution systems in a second, but some can benefit from, if there's a dead end, the water doesn't circulate through, maybe introduce flushing. Get a chance to get the water through, get it moving, find a way of dealing with the problem, high chlorine, low chlorine. You got to look at it. So if you had that assessment tool as a community, you'd run through it, you'd find out, okay, maybe I got some risks there. You'd find a solution. And the big thing is, if it is a technical problem, reach out for some training. Get more comfortable with how I would add the right amount of disinfection. How do I deal with my system?